Hello, I'm Tommy McAfee, and welcome to this talk on doing DevOps with the 2.0 Helm Chart. So the Helm Chart is a really quick way to get started with installing Couchbase Cluster. It installs the following resources automatically. So you have the Autonomous Operator, the Admission Controller, which does validation, Couchbase Cluster, and also Sync Gateway, which the Couchbase Cluster can replicate data to. And there's ways of sort of installing that in the same Kubernetes cluster or in external Kubernetes clusters as well. And the Helm chart sort of helps with that configuration as well. The default stack, so if without any customizations, if you just were to do install of the Helm chart, you would get the operator with the cluster. If you wanted to also include Sync Gateway, you can set an override to install Sync Gateway true. And if you wanted to also include TLS, you can set TLS generate. And so this will generate certificates for you. It's really good for testing out secure deployments. You don't have to sort of create all of your CA certificates and then the client and certificates and keys as well. It sort of does all that for you and applies it to Couchbase cluster in a real simple way. So this approach is a single chart, but there's a selective install or selective deployment approach to it where specific components can be enabled or disabled. So generally when starting, if you just wanted to give it a try, as I mentioned, these are the general components that you would get by default. Sync Gateway can be enabled. If you're doing things like installing the chart twice in the same namespace, you probably want to set operator and admission controller to false. If you are installing twice but in the same Kubernetes cluster, then you definitely want to set admission controller to false because the admission controller is already a cluster-wide resource. So there's really not a need to install multiple instances of the admission controller within the same Kubernetes cluster. So a little bit more detailed about what specifically is installed along with these resources. So the operator means we're installing the deployment and the RBAC roles that go alongside it. And then for admission controller, we're also installing the admission controller along with validation webhooks and services. So this is what's doing the validation when you attempt to create a cluster to ensure that when you update it down the road, that everything is will work as far as like a runtime. You won't experience errors down the road. And also just the RBAC stuff that also goes alongside the roles and service accounts that goes alongside the admission controller. And the Couchbase cluster gives you a 3-node Couchbase cluster with the secret and 1 default bucket. So some optional resources that come alongside the Couchbase cluster is you can install users, so RBAC users. It's very simple. It provides a simpler way of just specifying users, and behind the scenes, a group is created for the user and it's bound to the group. And then also for secrets, we mentioned that, just mentioned that. And then RBAC for a Couchbase backup. So the Helm chart doesn't actually create backups for you, but it is able to create an environment for that is backup enabled, backup and restore enabled by creating all the RBAC resources that you need in order to quickly create a Couchbase backup resource on the cluster. And then for Sync Gateway, creating the Sync Gateway deployment and exposing service from cluster IP to node IP to load balancer if you wanted your Sync Gateway to be externally exposed. So we'll come back to Couchbase specific features for the Helm chart. I wanted to dive quickly into what's new with Helm 3 and why it relates to Couchbase chart. And if you're currently in Helm 2, hopefully this will motivate you to do 2 things: to upgrade to 3 and try out Couchbase and how we're using some of the cool things that are in Helm 3. So there's improved Couchbase resource, custom resource definition management. Before it was a 2-step process of installing CRDs and then installing the chart, but now it's a single step. where the CRDs are installed, made sure they're available before use. And then it's a lookup function, which is really nice because with Couchbase, there's authentication that happens. I mean, one of the purpose of authentication is securing your cluster, and you want to be able to hide the username and password as much as possible. And one of the previous drawbacks with using Helm is that you have a values file, and it requires you to specify a username and password. And even though that stuff gets packaged up into secrets, the pipeline of getting that into a secret and into Kubernetes was insecure, and also prone to errors when you would manage the Helm chart and do things like updates. So I'm going to dive a little bit more into this lookup function and how we're using it with our chart, and then I'll come back and give a more general view of what else can be done with the chart. So going further into how we're using lookup functions for the Helm chart, one of the benefits is that it allows for reusability of existing resources. So when you install the Couchbase chart, it generates rendered templates of secrets and the Couchbase cluster. So one of the use cases for that is if you're installing, say, a local chart and then a remote chart. Let's say you install the remote chart first, then you want your local chart of Couchbase cluster to know about the remote, so you can do things like lookup on the remote to see what the UID is in order to easily generate replication IDs. So this streamlines the normal approach of doing kubectl get and dumping out the YAML of the Couchbase cluster spec to see what it is, where you can have it all in a single Helm chart that is configured for XCCR to be able to fetch whatever information it needs to know about and to install and configure and set up replication. Same use cases for Sync Gateway, where you want to install a separate instance of the Couchbase chart and you want to enable mobile, then you can also allow, and this is a way that we can inspect what the secrets are on the Couchbase cluster chart in order to install a Sync Gateway as well. And along with reusability, one of the benefits of reusability is it allows us to do password auto generation as well. So this is just a look a little bit deeper into how the code works inside of the template of the Helm chart. So this pseudocode, or this code here, is basically saying, try to look up the secret that's being used as the admin secret. If the secret does exist, then let's reuse it as the password. If it doesn't exist, then let's generate a password. And that basically allows you to do things like upgrade the chart, but not have your password upgraded or changed or anything like that when you after the chart itself is changed. It's kind of a subtle change, but it's actually very helpful because it adds for an additional level of security, because now when your passwords are being randomly generated, everyone who's using the Helm chart basically has a different password. No one knows about anyone else's password. So getting back to the selective deployment and what you can install. So just an overview again of what we have. So operator, admission, cluster, sync gateway. There are different overrides that can be provided for each one of these. So I'm just going to give kind of an overview of what certain deployments would look like when you want to customize your installation of the operator chart. So a common example is wanting to do things with external DNS. The overrides that you would provide for that would be for the networking, changing the service types of load balancer, also providing external DNS domain. If you're just doing sort of a test of your domain and wanting to make sure your external DNS is working correctly, you can generate TLS before you've actually even gotten any of your secrets or your certificates from your registrar or anything, just to see if it's working. These are going to be self-signed, so you wouldn't want to do that in production. But if you have all of that, then you can also directly put those into a secret and then provide them to the Helm chart and then do an install here. And so we'll still install the entire external load balance cluster and reference the secrets that you've created beforehand. Another sort of advanced configuration would be wanting to do multi-dimensional services. So isolating per node services, you generally want data and index or data itself separate from things that are doing searches on that and queries on that. And so here's an example of setting a server config. So the name of the server config means it's multi-dimensional in the sense that you have a 5-dimensional config and a 3-dimensional config. One is default, and so we have 5 data index nodes, and then we have 3 query search nodes. And you also want to set anti-affinity to true when you're doing this, because it will allow you to ensure that these data index pods don't end up on the same Kubernetes node as these query and search, as the intention here is to isolate the workloads across Kubernetes nodes themselves. Some things to note when you're doing things like custom multi-dimensional service and things like that is, or just in general with Helm, because the same thing will happen when you're doing things with buckets. With our operator chart, is when you provide overrides, they're actually merged with the old value. So if you have a cluster config, server config, and you have a 3-dimension, config with data nodes, it's still going to include the old original values that ships with the operator chart. So we have by default a 3-node. And so if you provide this, it gets merged or added to the chart. So you might be surprised if you set this as your value overrides and you see 6 nodes. In order to deal with that, what you want to do is you want to set the default to null. Another way to do that is you could just, instead of using data only because it's simply a name, you could say default itself is size 3 with these services. But just remember, it's the same thing with buckets. There's a default bucket, and then you can provide your own buckets, but if you don't want the default bucket, to set it to null. And configuration with adding persistent volumes. So specifying the actual pod config looks the same way as we configure things with Couchbase cluster through the operator outside of Helm. You have the volume mounts that you're referencing, it's named Couchbase, directly referenced to claim templates as well. Sync gateway configuration. So here's an example of installing sync gateway. So you enable sync gateway to true. Generate TLS, so Couchbase cluster will have TLS, and then it also will use TLS sync gateway. So one of the nice things about having everything in the chart is that the sync gateway can be automatically configured to use the Couchbase cluster to generate its own certificates from whatever the CA was for the Couchbase cluster, and exposing it as load balancer. So with a single command, you can have this sort of setup going and externally access sync gateway, which allows you to sort of isolate Couchbase cluster itself and just interact with the sync gateway for setting and getting data. So aside from just configuring Couchbase itself, you can include other charts alongside Couchbase operator. So there's a core OS chart. Core OS chart is really good for doing things like XTCR, or if you have a situation where you want to point to sync gateway on a different cluster, whether you're doing internal peering, network, things like that. You can do DNS forwarding through Core OS by installing Couchbase chart alongside Core OS, and Couchbase can be configured to know exactly what the services that are being created by Core OS and forward its DNS over there. Grafana and Prometheus, so I'll get into that specifically, but this is just a one-stop, deployment of fully monitored installation with Prometheus exposing metrics, and Grafana sort of giving you a nice graphical interface of that. And Open LDAP, So let's discuss a little bit in the RBAC, talk about the operator, where you can install a Couchbase cluster and install Open LDAP, and then automatically have your cluster configured for external user authentication. And of course, I mean, you can install all of these at the same time if you really wanted to, and add in other things that are even not a part of this as well. So here we have Couchbase Operator, and we want to specify how that should be configured. So we have cluster monitoring. Specifically, we just want to enable the monitoring for the Couchbase Operator. And then for the Prometheus Operator, just basic configurations where you want to add a service monitor as well. So Couchbase will expose statistics to this exporter, and the Prometheus Operator will also provide service monitors that can be fetched and used for Grafana. So I'm going to do a demo of installing a basic Couchbase operator chart, and then also show how it looks to install the Prometheus monitoring stack. So to get started, so there is a Helm repo. So we've added our Couchbase repo, which is Couchbase Partners. When you're installing the Couchbase chart, you want to do a Helm repo install of Couchbase. And then if you've already had it, you want to do a Helm repo sync. But anyway, Helm install, name of the chart. So we're going to just call it demo. It can be anything. Couchbase operator. So we see everything that was installed here. Operator, image controller, tells you how to access the admin console, password that was generated, and ways to upgrade the chart. So it also says if you want to show the status again, it's basically to see this again, you just do status. I'm going to check out the logs here to see where we are with creating everything. Looks like we are creating the cluster. So by default, you get a 3-node cluster. Everything is being added to the cluster, so rebalance is going to happen. So if I do Helm status demo to just see this again, I want to connect to the admin console. So I'm going to port forward this to 8091. If you were using external load balancing, then you would actually see the name of that load balancing service instead. So let's check out our cluster. Password that we got there. And there we go. So we have everything from the defaults of the services. And we have a bucket, just basic things here. And so I'm going to Helm list. So I'm going to delete that demo chart. And I'm going to show an example of, so we have a couple of, in the GitHub repo, so we have a couple of things, examples here. So if you actually do a git clone of the GitHub repo, so there's the operator chart, that's what I just installed. So there's also Couchbase Prometheus. So if just to check out some of the things here that I mentioned in the presentation. So the requirements, oops, shows that we have operator and Prometheus operator. If we wanted to see that values files looks like. So it's a little bit more in depth here than what I showed in the presentation, but essentially you can see these are the these are the overrides for the Couchbase operator. These are the overrides for the Prometheus operator. Everything is specified in a way that makes it these two charts to work together really nicely. So in order to install this, usually what you want to do is Couchbase Prometheus. Since this chart itself isn't published, it's from our Git repo. You want to do a build of the depths. Sorry. Helm dep build. And now we can do Helm install monitoring chart. So what this will give us is, yeah, so you can ignore, these are info logs that come from the Prometheus operator chart itself. Apparently they're using an old CRD install hook from previous Helm. That's something that don't necessarily have a lot of control over besides maybe forking the Prometheus operator chart, but not necessarily something that has to be done for this. So what we have installed here is the Prometheus endpoint and Grafana here, and we have our Couchbase cluster. And let's see, let's do kubectl git pods. Let's see sort of from the command line what we have going on. I am going to, let's check in on our logs here. Okay, so cluster is already being created. Let's do status again. And expose the Grafana endpoint this time and have a look at what's going on here. So it says the login for that is there in case you miss it when you're installing this chart yourself. Actually, if we want to change our password, it's fine. We'll just keep it as it is for now. And go to our dashboards. So this creates a Couchbase dashboard for you. And what I like to do is change the interval to 5 minutes to get more of a granular look at what's going on. So there's some default statistics that are being monitored here. But the really nice thing is you essentially have a Couchbase cluster and you have all of the statistics and everything wired up with a single command. And it creates the dashboards for you. It generates the queries for you to monitor. So I think that's it's really nice just as far as like wanting to get a feel for what some of the third-party solutions that can be added on with Couchbase through Helm. So by having the operator chart within Helm itself, just opens up the possibility to sort of configure it and wire it together with other charts. Okay, and now I'm going to demonstrate an XDCR scenario here. So I have two AKS clusters here in Azure, local and remote. And the two clusters are paired using Azure Network Peering. So the first thing is I'm going to install a destination Couchbase operator chart in the remote cluster. So let's just make sure we have kube credentials config set correctly. Okay. So I'm going to install the Couchbase operator chart, just use all the defaults. The name of it is destination in the remote cluster there, in the remote namespace of the remote cluster. So as this starts to create pods here, let's check. Okay. So the cluster is creating. One of the things that we're going to be doing here is demonstrating the use of the lookup function. So as this cluster creates, it creates a UID. So we're going to use the lookup function to generate values that the local cluster can use to install. So in order to do that, I have created a chart here called core DNS chart. And what it does is uses the core DNS chart as a subchart in order to do network forwarding over to the remote cluster. And it also generates remote values. And this is also in GitHub. So there's links to that as well. So this is the repository that it's in. So in order to use this, first thing you want to do is Helm template. We don't want to do Helm install, just XDCR cross networking, and just dot. This will just kind of show you what has been collected. So we see our UID has been collected, things about the bucket. Another thing is, since we're doing remote networking, cross networking, there is also information that's going to be used for core DNS, specifically network forwarding to our remote, to what is, this is the remote network that we're on, but it collected it. So for instance, if you do kubectl get services, actually let's do endpoints, kube system on our remote cluster, we see that we're going to have traffic forwarded to this specific endpoint, which means that with the local cluster, we'll be able to forward traffic over to our remote cluster here. So I just kind of dumped out those values. What you want to do is save them to its own values file. And now we're going to switch over to our local cluster. So what we're going to do here is first install core DNS, which will consume the values that knows about the remote cluster. So Helm install remote values YAML. Okay, so we have core DNS running and a service. So, and then we're going to use an additional, so now we can install our local Couchbase cluster, and this cluster is able to consume both information about the remote cluster and from core DNS. So just to show what's being installed here. So we have the Couchbase operator. This was all generated. So the cluster information was generated to enable XDCR, what actually is the destination host name, and how to authenticate with that cluster has also been collected. So now if we do Helm install -f remote values source using, and so for this to work, you have to set install equals true. So this is just kind of a modified umbrella chart of our regular Couchbase cluster chart. Install true. We now have a source cluster. So this cluster will start and it will be paired to the remote cluster using the information that we fetched from the remote cluster once it gets going. So we can get started ourselves with checking out what the cluster looks like. All right, so check out what we have here for XCCR. So we have our destination cluster set up, replicating the default bucket there. Status is replicating. This is the source cluster. Check out our bucket. So let's load some data here. And we'll be able to verify. So what's happening is we create some documents. We should see some outgoing statistics happening. And now if I switch to my remote context, and get the login information for the remote cluster. So I'm just resetting up the port forwarding there and sign in. Okay. Okay. And so we have on the destination cluster document, same documents here created. Since we're in the destination, there's no remote. And yeah, so looking good. So that's an example of, you know, how in a couple steps here, how we can use the lookup function to combine different charts. So we use some core DNS here as well, created an umbrella chart using that in order to set up an XCCR scenario using Helm as well. So check out the official Helm documentation. If you want to see some examples, this is a GitHub repo I was referring to that has the Prometheus chart, an example of using Open LDAP. And then you can see some things with the core DNS as well. And then there's a blog that's a really nice blog for everything I just did with the Prometheus. That's also in a blog for Helm, just searching for deploying operator with monitoring using Helm, something like that. It'll probably be one of the first things that you see going on there. Well, thank you. Appreciate you guys for hanging out for this, and yeah, enjoy using the service.